In the NFL, when a quarterback steps out of the pocket, the play changes instantly. What was once a scripted design turns into controlled chaos. Receivers break routes, defenders scramble, and the quarterback just has a few seconds to turn pressure into opportunity. These moments are where great quarterbacks separate themselves, extending the play, keeping their eyes downfield, and finding the right receiver at the right time. This project focuses on those exact moments. Using NFL tracking data, we analyze every out-of-pocket frame to answer one question. Who is the most optimal receiver for a quarterback to throw to when the play breaks down? We created a metric called out-of-pocket decision score, or OOP score, to capture how good a quarterback decisions really is when the play breaks down. The score pulls from over 20 different attributes during the exact frames where the quarterback leaves the pocket and evaluates which receiver is truly the most optimal target. It blends game context like down, distance, and defensive coverage with real movement data from both the quarterback and receivers, including speed, direction, and orientation. On top of that, it factors in coverage quality, such as receiver openness, depth downfield, and how each option ranks relative to the others during that play. Now let's see the score in action. Here we see Brock Purdy against the Ravens go out of the pocket to his left and hitting Kyle Juszczyk in the flat for a 5-yard gain. Our model gave Kyle a score of 0.367 due to him being very open with separation. However, another receiver, Ronnie Bell, had a higher score of 0.418 due to being farther down the field despite being more covered. Let's rewatch the play. We see Bell as less open than Kyle, but farther down the field. The scores are still relatively close as the model favors openness and boosts the score with more separation versus distance down the field. However, both Bell and Purdy are running in the same direction towards the left sideline, which helped Bell's score exceed Kyle's. Here we see Justin Herbert against the Minnesota Vikings on 3rd down, scramble to his left, but then throw a very impressive but slightly dangerous pass to Keenan Allen on the right side of the field. We gave this score a 0.170. Rewatching the play, the model identifies Joshua Kelly, the running back who was lined up on the left-hand side of the line of scrimmage, to be the most optimal receiver with a score of 0.547 as shown in the rewatch. Kelly had a much higher score than Keenan due to the fact that he was much more open and on the same side of his quarterback. However, Keenan was not traveling in the same direction and sat in the gap of the zone on the right side of the field versus his quarterback's left. The model did not do a good job, though, of giving Keenan a higher score due to it being 3rd down, and Keenan's additional yardage was much needed to get a 1st down. This is an area of improvement for the model.